Performance is a super important part of any web or mobile application, and it's not just something we want to check a box for, it's something that helps everyone. From maybe somebody trying to browse your app, or maybe just how much we're actually going to pay to allow somebody to do so. So let's see what we can do from a media perspective. I'm Colby Fayock. I'm the one hugging BB and Kylo Ren over there. I help others get the tech out of the way to solve real challenges with the web. I work with the dev community by building educational content and working with the dev community as a developer experience engineer with Cloudinary. You can find me pretty much anywhere on the web by just Googling my name, as I'm the only one in the world. So starting off, let's take a look at a few examples of media in everyday websites, where we can kick it off with Amazon, king of e-commerce, where they use images to showcase available products and categories. Here we have Star Cadet, where I'm a big fan of their Final Space merch. They take advantage of GIFs to display video-like category and product images. It's a bit more of a creative approach, taking a very static medium and making it exciting. Hashtag renew Final Space. Or NASA, exploring places that are out of this world, where we can get high-resolution images from space, which is just mind-blowing. Or something fun like Giphy, where we can share our reactions with an animated image. Who can't express themselves with Michael Scott? Now, as you might imagine, given this talk, we're focusing on media for this kind of thing, or images and videos. And let's not forget about our audio friend that gets left out quite often. While it's awesome to be able to enjoy these large images and GIFs on sites, it comes at a cost, which we'll talk about soon here. So what can we do to help reduce that cost? But you might be wondering, where does media fit into my application? Everywhere, of course. It's part of the web. Whether it's a simple profile avatar, an embedded video, or an interactive experience, you're likely using media in some way. But we're here talking about the Jamstack, so let's see how it fits in there. Starting off with your web app, we have some crucial components, like the page itself, which is ultimately HTML rendered in the browser, that might or may not be built by a framework. But then we likely need some kind of dynamic data, where we could use SSR. I like to deploy pages statically to reduce the overhead and improve performance, so we can make any API requests to the browsers that need to hydrate any kind of personalized information for our visitors, or better yet, maybe we can do that in an edge function. And then we have our media, which plays an important role in providing visual context, helping people better understand what you're talking about or what you're trying to sell, but also as a way to be creative, creating engaging experiences rather than just a bunch of text on a page. But okay, that's pretty basic. I've seen images and videos on a page before. Why should I care? This is where we come back to the cost that we talked about earlier. Let's take e-commerce for example, where it's one of my favorite types of sites to work with. Conversion rate is the percentage of your traffic that actually buys something. There's a ton of studies about how website speed directly correlate to conversion rate. eBay, for instance, found that a 0.5% increase in their conversion rate with a 100 millisecond load time improvement. And Portent found the same correlation with their data, where they have a site that loads 1 second has a conversion rate of 3 times higher than a site that loads in 5 seconds, or a site that loads in 1 second has a conversion rate 5 times higher than a site that loads in 10 seconds. So that means that while a bunch of images and videos are going to be great for our user experience, that media is going to take up the vast majority of that size. So if we don't pay attention to how we're delivering it, we're going to bloat our pages and destroy conversion rate. So what can we do to help actually optimize our delivery? Let's look at some examples of images. To start off, while JPEG is a great option, there's more modern formats that can help us deliver high quality images at reduced sizes. WebP and AVIF are two great options, and depending on that image can bring some drastic reductions in size. We can also compress our images to a point where we're not actually impacting the visual quality. Maybe it won't matter for this tiny little thumbnail we see here, but we want to display our images big and clear. We can let tech automatically decide how much to actually optimize it. That way we can optimize it as much as we can without a visual difference, and we're not over-optimizing and we're not wasting precious kilobytes in downloads. If you're working with high quality imagery, your source files might be huge. If you serve them as is, the browser has to resize them down anyway, so you're just wasting bandwidth. Resize only to the images sizes that you need, and don't try to just crunch an image just so that it's smaller with a file size. You'll end up with super blurry images or pixelated images. Modern image delivery can give you the exact sizes you need on the fly, so take advantage of that. Bringing this all together, we have some pretty amazing results. Using modern formats, letting tech automatically optimize our images, and serving our images in sizes that make sense for our web apps, we were able to slash this particular example from Unsplash down from 4.3 megabytes to 51.2 kilobytes, all without sacrificing quality. So hopefully I have you convinced now that this is actually pretty important. But how can we work with this in our Jamstack application? And how can we actually improve our developer experience and ultimately delivering better experiences to our visitors? This shouldn't be new to anybody, but regardless of which framework you use, except Next.js, who actually yells at you inside the linter, but you can actually use HTML image tags inside your framework, importantly, including a width, height, and an alt, in addition to the location of the image. Not too different is the basic video tag, which has a lot more options that we can get into, but ultimately you need your source and a width and a height. The more interesting thing is sourcing these images and videos, where this could come from a variety of sources. Could be a headless CMS or a database. Maybe all your data is pulled together in a single data layer, but ultimately the image and video tags you're using dynamically get their sources from the data. Where now maybe those images are videos and wrapped in a component. This is JSX, which you might be familiar with in the React world. We're passing that data right into our video and image tags. But when does this happen? What's connecting the dots? This is where we start to think about the framework or library, where we have a ton of options available to use, and it doesn't have to be a fancy one. We don't need to ship a huge bundle of JavaScript to the browser, especially if we're just dumping static content. But we start to see the higher level flow, where we have the location we're storing the media references, we have the framework that's doing the hard work of pulling that data into the application, then ultimately using the HTML we know and love to take that data and put it on a page. Now this is a pretty linear solution, but it's only one solution. We could alternatively build our site by using local files from our project. We don't necessarily need a database to do that. But then once we deploy to Netlify or something, we can install the Cloudinary plugin, which auto uploads on that build. Or we could even orchestrate whatever external data we have, whether it's Cloudinary in a database or 5 other services, pulling that all together in our services or data layer and having a singular connector into the framework of our choice, where the point is we have a lot of options about how we pull this all together depending on our needs. But all this is making a big assumption that somebody somewhere in these solutions thought about optimizing your images and videos. But as we all know, it's not safe to make those kind of assumptions. So peeling back the layers of our stack a little bit, we can start to think about our optimization needs. Starting off, we can do this manually. As much time as it takes, we can work through our folder of 100 images and be happy with our results. But you know this is where this is going. This isn't going to scale. And beyond all the work that actually needs to be done, we're back to assuming that everyone who adds an image to our project is actually going to do this. Maybe they're assuming that you're going to do this. Either way, this doesn't actually fare well. A better solution is to start to automate this. There's a lot of great CLIs and libraries out there to help out with this. Some that you can run on the same directory of images on your computer. Some you can actually pull in and script to run during your build and deployment processes. This works fairly well. You're able to work through all the images, store them somewhere, and reference the optimized versions wherever that may be. You can even get smart with this. Generate a few sizes. You don't want to go overboard, but at least you don't have to serve the same high resolution image everywhere. But again, this doesn't scale. Oh, your thumbnail size changed. Well, you have to regenerate all the sizes again. What if you have 2 use cases where that's too small for the original? Well, you can generate a new size within that mix. Or you can sacrifice the quality with a small image or sacrifice the bandwidth with a big image. None are great options, but you make do. Or do you make do? I see you over there serving blurry images to your visitors, and I see you over there serving images that are way too big for your visitors. But guess what? We can do better and we should do better. Let's again start to list out some of our images, where these are the source images and they're never going to change. Someone can certainly upload more, someone can even delete them, but we're not going to modify them. Instead of manually creating new versions, whether that's by using some kind of GUI or by running a script, manual as in we're managing creating those different variations, let's just throw a little URL parameter on there where we have QAuto or automatically figure out the best way to compress this thing. We're not touching our source file, but now we're saying, let's serve an optimized version of this. And instead of creating those different sizes that we may not know what they'll actually be a week from now, let's again just add some parameters, setting W or width to 800 or H or height to 600. We're getting the exact size that we specify, again, not touching the source file, but serving an optimized resized version of it. Technically, we don't even need the height. It will automatically scale to the original aspect ratio. We can of course crop it to a different size, but keeping it simple is always a good bet. And we saw earlier that by using a modern format, that on top of optimizing our image and on top of resizing it to a responsible size, we can drastically cut down the size of that image. This is something that's especially tricky to deal with at scale. So let's just tack on another parameter. Here's fauto, or format of auto, where we're going to see that we're going to get the most efficient format for that particular asset. On top of that, we're going to automatically detect what formats can visit for your actual supported browser. Not all browsers can support every modern format, and we want our images to work on all browsers. So this is important to make sure that we're actually being able to do what we can, where we can. We're checking all the boxes, delivering in modern formats, compressing as much as we can without distorting the image, and we're serving in responsible sizes. Now, the nice thing about all these controls right inside the URL is you can swap them out, particularly the width or other transformations on the fly. Because the URL is our headless API, so the developer or implementer can control these sizes and use exactly what's needed for the application. And for the record, all this works with video as well, or animated images, which can potentially have huge savings, given they're naturally usually going to be bigger file sizes. So how does all this work? Expanding on our example here, surprise, I'm using Cloudinary for all of this. But when we serve the image on this page, it may or may not actually exist yet. So first, Cloudinary checks to see if the image exists. If it does exist, Cloudinary retrieves that from cache. We don't have to wait for any processing. It gets served fast from the CDN. But if it doesn't exist, Cloudinary processes it to generate that asset. It uses those parameters that we talked about as instructions for how to actually build that image or video. But once it completes, it stores it in cache for later use, and then it delivers it similarly from the Cloudinary CDN, meaning this only happens the first time. So all your assets will be served nice and fast for the vast majority of your visitors. Now, practically, we wouldn't expect you to manually construct that URL, even though I know some of you cool cats out there are doing just that. Yeah, I'm looking at you. But we can use SDKs and integrations to make this much easier. For instance, we recently launched Next Cloudinary as an easy way to work with Cloudinary in the Next.js project. To start, instead of building an HTML image component or the built-in Next image component, we'll use the CLD image component, where we can pass in the width, height, and the alt, but now our source is going to be the Cloudinary image ID, which will give us an image URL that looks something like this. Where breaking this down, we see the width and the source, where the alt gets used in the resulting image tag itself, so we wouldn't actually see that in the URL. But if you're wondering what's up with the height, Cloudinary will actually preserve the aspect ratio by default as that parameter, so we don't need to pass it into the URL, but we still need it to prevent layout shift in the image tag, which is super important. Layout shift is when something like an image or a video is loading, but the browser doesn't know the size of it before it actually loads. If you don't add the height, it doesn't know how much space to save for that particular area. So before your images load, you might see some content that gets shifted down as your images start to load. Now, you've likely seen this happen in the past on websites due to ads, which is pretty annoying. So we can avoid this by adding our height. Next, we can start to add some more interesting features. Say I have a bunch of images in different widths and heights, like this space jellyfish here that's 800 by 600. What if I want them all square? That's yet another crop that I would have to manually add or script, or I can dynamically crop that. By setting my dimensions in a square, setting my crop to fill, meaning it'll only take up all the space inside of the square, similar to a CSS background size cover, and a gravity of center, meaning we'll just anchor to the center of it, I can now easily get a crop of my image. And to the scalability factor, likely you're looping through a bunch of your data to show these images, so this just works with all of your images. And this works similarly if I want a smaller image, such as if I want to show a thumbnail of this image. This doesn't just resize it in the browser, this delivers a smaller image. This extends to responsive sizing as well, which using the Next.js image API will automatically generate responsive sizes based off of your configuration. And honestly, there's a lot of other things here that I can talk about. A lot of cool, interesting features like color replacement, background removal. But how about I just show you? So we're going to check out some benefits of real-world image optimization. We'll serve this image up exported straight from Illustrator inside of a new Next.js application. As you can imagine, it won't be the most optimized image in the world, but we'll see how we can optimize it, crop it, and resize it, and even give it a little bit further and have some fun with it. Let's dig in. All right, so digging in, I did a little bit of prep work for this where I ran npx create next application, where really this is going to give us a fresh start for a new Next.js app, where we can see now I'm running npm run dev. We have my local server, which has my Next.js application. And if we start to look inside of the code, we can see that I have my index.js page and really nothing fancy is going on here. It's really just the standard Next.js page. So what I'm going to first start off by doing is I'm going to just clear out all the content inside of the page here, as I really don't need any of this. And it's just going to kind of get in our way as a distraction. So first I'm going to clean that out. But now let's head back over to our browser, where what I ultimately want to do is I want to load up this poster. And this is the jam.dev poster image. Brian and the team were gracious enough to send this over to me so that I can use it as part of my demo. But what I ultimately want to do is I want to load this in my application. I'm going to load it in raw. We can see that it's 1.35 megabytes. It's a PNG. And we're going to see what that looks like when we're actually loading into the page. But then we're going to see what we can do to optimize that. Now, as we talked about, images can come in from a variety of sources. So we never know what we're going to actually get. So realistically, we might get raw, huge images like this coming into our application. So what can we do to automatically make sure that we're always optimizing? So first, let's actually get this in the application. Now, heading back over to Next.js, the first thing I want to do is just simply load this on the page. So I'm going to copy the URL. And to start off, I'm going to use a simple image tag. So let's add my image, and let's say the source. I'm going to add it on a new line. And bear with me, my computer is a little bit slow right now, but let's say my image source is that. My width, I'm going to get my width and my height in a second here, but just adding the parameters. And let's say the alt is a robot fighting off airplanes in a city with our closing tag. Now let's get that width and the height quick, where we have 1638 by 849 by 849. And now at this point, all this is going to do is load that image on the page. Now let's see what that looks like. Already done. It loaded up. We have our image. Now what I want to do is open up the network tab so we can see realistically what's happening here. And looks like one other thing I want to do is by default, it's going to just expand the size of the image. So I want to just add a quick style to my global style sheet. I'm going to say image, where I want a max width of 100%, and I'm going to set a height to auto, just so that we can see the entire image the entire time we're working with this. Perfect. So we can see what it looks like. And if I open up that network tab, let's see if it came in or if I'm going to need to refresh. Yeah, I'm going to need to refresh. I'm going to refresh the page so that we can actually get that image request in there. Now we can already see that when that image is actually loaded on the page, we're already getting that size. Even though we don't see it yet, we see we're getting that size of 1.4 megabytes. Now that's because we're just loading the image raw. It's just straight from Cloudinary. It's the PNG. We're not doing anything to it. We're just delivering it as is uploaded into the account. And that's fine. Maybe that's the specific use case, but when we're building for the web or for really any application, we want to make sure we're delivering as optimized of an experience as we can, because usually people don't care about seeing pixels that they can't actually visually perceive. So we want to make sure that we're just reducing that bandwidth in the actual page load as much as we can to deliver a nice, snappy, performant application. So what can we do to reduce this? Well, let's check out Next Cloudinary. So to start, I'm going to need to install Next Cloudinary, and it's available on NPM, where I can now run in my terminal npm install Next Cloudinary. Well, what that's going to do is go and install the Next Cloudinary package from npm. Now let's let that run in the background, but in the meantime, for configuration, there's only one other thing I need to do, and that's set up my Cloudinary cloud name as an environment variable. So I'm going to open back up my code editor, and in the root of the project, I'm going to add a new file, .env.local, and this is going to be my environment variables file, where once that's up, I can run next or add next public Cloudinary cloud name, where I'm saying that I want this to be a publicly available environment variable, and it's going to be my cloud name. So that's going to be, in this instance, I set up the jam dev. But ultimately, the Next Cloudinary library is going to look for this environment variable so it knows where to grab the referenced images from. Otherwise, it won't know where to grab those images from. So this is all we need. But now I can head back to my terminal, which hopefully by now it's now installed. So I'm going to spin back up my development server, npm run dev. And now let's see what we can do to actually load in our CLD image component, which is going to help us load our poster. So back inside the Next.js application, let's check the terminal out to see if it's still loading. We're good. I'm going to refresh the page. But back in the actual code, what we can now do is I'm going to replace the next image with a destructured CLD image from Next Cloudinary. Then I'm going to scroll back down to my image tag, and I'm going to simply replace the image tag with CLD image. And then I have one more thing I want to do to the image tag is I'm going to remove all the URL parts from this actual address. Now, the Next Cloudinary library can parse some URLs. It needs to get a little bit better at that. But ultimately, being able to pass in our public ID is the most confident way that we can be sure that we can construct the image URLs to point to the right image. So we're going to pass in that public ID. I'm going to hit save. And let's head back over to our account, or to the Next.js application, but let's see what happens when it reloads. I'm going to actually force the reload to make sure that I get the image request popping up inside the network tab. Now it might take a second here, but what's happening in the background is while Next.js is building that page, the CLD image component is now going to construct the Cloudinary URL, all happening in the background, so we don't even need to think about that, but it's going to do so with the optimization parameters that we need, like we saw earlier in the talk, in order to deliver this image as performant as we can. Now, as soon as we see that load, we notice two big things. Instead of the 1.4 megabytes, we're now delivering this at 119 kilobytes. That's a drastic difference. And the primary reason is because we're now delivering this as an AVIF. AVIF is just such a more efficient format than PNG. And on top of it, we're just getting a lot of optimization efficiencies in here because we're using the quality compression as well, which is going to compress it to a point that it's not going to be perceivably different. Now, this is without doing anything else. All we're doing at this point is serving it at its original size, and we're serving it with the automatic optimizations. Now that means that we could probably get even more benefit out of this. Now, if we go back and we can see that we have 16 by 38 by 8 by 49. Now let's try to do some math. I'm just going to serve it at half because I don't want to try to do some fractional math on there. But let's see, 849 divided by 2. Not going to add that 0.5%. I think a half pixel isn't going to break the bank here. But we can see, let's see when that reloads. We can now cut that down by serving a reduced file size, which we didn't even notice the difference because of the viewport that we're seeing in the browser. We now cut that down even further to 35 kilobytes. And that's all because we were able to dynamically serve it at a smaller size than we were actually doing before. Now let's do some more interesting things with this. How about if I'm actually working with this image, I don't want to show the entire thing. Maybe I just want to show the little robot, maybe just half of it. I need it to be in a square format. Maybe I'm posting it to Instagram, though I think they take different dimensions now. Anyways, we want it to be a square, and I just want it to be focused on that robot. So what can we do to crop this in a way that's going to give us the best result? So I'm going to head back over. I'm going to add my crop of fill like we saw earlier in the talk. And what I'm going to actually do is take the same height parameter and add it as my width. Now, I can actually kind of just make this whatever I want at this point, since it's going to be a smaller and then cropped version of this. But then I'm going to also add my gravity. Now, if we saw before, we were talking about how we can center that gravity to be in the actual middle. But since our robot is on the far left side, we want to set it to west. Hopefully the camera, if you're looking at this, doing the right hand signals, but our gravity, let's set it to the west because we want it to be on the west compass direction side of our image. So we're going to set that parameter, and now let's look back inside of the browser. And as soon as that reloads, we can see that, first of all, because we're still now serving ultimately a smaller image, we're now down to 27 kilobytes. But we could see that we were able to just that easily crop it down to that square. That's the whole image. That's not just a visual impact of it. That's the image that's getting delivered. Oops, I don't know what I just clicked. But we were able to do that dynamically with just those few parameters. That's what I clicked. So I'm going to get rid of that. So what else can we do with this? Now, this is kind of where we start getting into some of the fun stuff. Now, how about I want to add some text on this. Maybe I want to add the jam dev at the top of here. So I'm going to now go here and let's just add a property of the jam.dev. Let's see what happens. It's going to load in the background, but as soon as that loads, we can't quite see it. We can see that it says something. Now, by default, the text property, we need to know where the text is going to be on the image, right? So at this point, it's really just going to slap some text on there and hope for the best. But the point is, now we can control that and actually configure it to something that we're going to use. Now, I don't know all these parameters by heart, so what I'm going to do is I'm going to head over to the documentation where I'm going to grab the text overlays. I'm going to grab an example of this where we're going to use the overlays prop so that we can have a custom configuration of what this looks like. So back in my editor, I'm going to replace this text prop with the overlays. Now I'm going to change cool beans with the jam.dev. We can probably get rid of some of this letter spacing and text decoration, though those are certainly options that we can use. Let's change the color of the font to white since it's going to be on a black background, I think. Now, gravity, again, this is going to be where we want it positioned in relation to the anchor. So the gravity in this case, how about we put it at the top of the image? I'm going to say north. And then for now, I don't need it to shift by the x-axis, but let's just bump it off 50 pixels off of the top. I can get rid of the angle. We probably don't need this width either, so I'm going to get rid of that. But let's just load this up and see what it looks like. And hopefully this font size is about the size we need. Now, once we head back over to the application, it's a little bit big, but now we can actually start to see the text and we can see how it start loading. So let's just have this font size that didn't select for me. And once it reloads, let's ship it. This is our new poster image for the jam.dev. I think we can call this a day's work done, right? But no, let's do something else and let's do something a little bit more fun. So we, of course, could add a ton of different text. We can add as many overlays as we want, adding different kind of descriptions, and this can be all dynamic. Maybe you have some different, you want to create a bunch of variations for this for ads, or maybe you want to just create this dynamically based off of, maybe you can have some, whoever's attending as a virtual ticket conference here, you can add it there. But let's just do something different at this point. How about let's try to remove the background from this. So the cool thing is I can go back, I can set up a new prop where I'm just going to say remove background. Now, when I go to this, when this actually starts to load, the tricky thing is usually if this is the very first time that you're loading an image without a background or removing the background, it's going to throw a 423 response, meaning that it's processing in the background. So that's only going to be the first time, but we can see that I did try to do this demo before, so it was able to reload based off of the version I created before. But now we can see that by just using that simple prop, we were able to easily remove the background from that. So let's add something else to that. Now, it just so happens that I have another familiar image inside of my account where I have this Bliss background. Let's add this as a background behind our robot. So I'm going to add an underlay where I'm going to specify my underlay as Bliss. And that's all I need to do. And let's see what happens when it reloads. We can see that my robot is fighting right in front of a field graciously, and we're all the better for it. But we can see this is going to be our new The Jam.dev poster. We were able to do a lot of practical things such as crop it, resize it, just to the specific dimensions we need. But we're able to do some more interesting dynamic things like add the text to it. We were able to remove the background. Now, practically speaking, this is amazing for e-commerce. Imagine if you have shoes or the shots of models where you want to be able to have control of the background completely unrelated to what the photographer is actually being able to do for you. So this gives you a lot of options for how you can dynamically work with your images and video, might I add, when you're actually trying to work in these different projects. All right, so this isn't likely the exact same image that you saw, but this is what I was originally going for when I created this slide deck. The cool thing is we saw the real world impact of loading our unoptimized images. We saw how easily we could optimize it with Cloudinary, and we even take it to an XP level with some fun transformations. If you want to learn more about how to work with Next Cloudinary, check out the docs at cld.media/nextjs, and it's also available on my GitHub. If you head over to spacejelly.dev or youtube.com/Colby Fayock and search for Cloudinary, I have a ton of use case driven examples, as well as a repository of straight up code examples using Cloudinary in projects. There's more to come, and I'm also taking requests. And that's it. If you want to learn more or chat about the talk, as usual, I'm everywhere at Colby Fayock. Also keep an eye out for Twitter where I'll post some resources. Thanks, everybody.
All right. That was great as always. I mean, Colby's always so entertaining, and the level of polish in his presentations is it kind of upsets me. I wish I was that good. Damn it. Next year I'm going to have Colby back to do a presentation about how to pre-record your presentations. Because
that's a great idea.
Yeah, and on top of that, I'll also just hire him to create the assets, because he'll just like code it and generate it. So
yeah, put a Windows XP background on everything. Sure.
Yes, exactly. Who wouldn't love that? So, as we mentioned before, Colby couldn't be here to answer questions. So we're just going to do our best to answer anybody's questions. We're also just going to talk about some of those things that like kind of struck us from the presentation. And one of the things that initially struck me was, we had a presentation yesterday about images as well. We're talking about today. Obviously, I know it's a big deal. Like I run into this in my site. Once upon a time when I did CFE, I actually had to pre-generate. Like I was spit out all the variations of the images, kind of like he mentioned. That worked when I didn't have that many, but then as I started to do more, it just was a nightmare. And then I used the kind of pre-built pipes in Hugo, because the site's built in Hugo. Next, he mentioned has that as well, but I think you do. One of the things you notice is you hit that boundary of like, well, what does that image component do? Like mine doesn't. Like it serves up everything as a PNG because that's what I told it to. It doesn't know that it should serve a different file format because your browser supports it, right? I mean, is this your experience?
I've had a really similar experience, yeah, in that it's like even and probably most of my experiences with Next.js as well, and their image component is really powerful, and it will process the images just like Hugo does and try to present them in a nice and efficient way. But there are a couple problems. One is that it might not be everything you need. Like for example, with Next, if you want to have that blur up effect, then you also have to have a base 64 reference to that or representation of that image. But I think for me personally, the bigger problem is that you have to store all those images in your repository. And we've got a lot of developers here probably working on a lot of independent projects where you want all your content, including your assets, are probably just living in the repository. And that can, like you said, Brian, it's like it's fine at first, and then you add image every week for years, and all of a sudden you've got all these images to the point where I'm working on the StackBit documentation site. It was like, okay, well, we don't want to store all these images, or we don't want to take up this much storage, because then working with Git gets really slow. So now we're running them in these external processors before we're even bringing them in and letting Next work with them, and then doing this other stuff on top. So yeah, just having a service like a Cloudinary or an ImageX or whatever service that might be to like do all of that work for you. It sounds amazing.
Yeah, and I mean, like if you think about it, my brain initially is like stupid, like in the sense of like, okay, well, wouldn't I want those files local? Isn't that going to be better, like faster? But except that in the end, when you're actually getting it in the browser, every one of these images is a request that needs to be fulfilled. That whether it's going to Cloudinary or going to my Netlify CDN, like whether it's hitting their CDN or the Netlify CDN or wherever you're hosting your site, like it doesn't really matter where it's coming from. And it's, based on what Colby said, it's going to cache it anyway. So like really that whole processing stuff is like a first time hit, which I mean, if I think about Next, for instance, Next, I don't know all of the internals, but I know it's like all of that is done server side as well. Anyway, like you have to actually push to a provider that supports Next Image, like Vercel, and I think Netlify also supports Next Image, and all that processing is done server side. So you're not losing really anything. I'd almost probably guess that you're actually going to get faster images from a Cloudinary than you are going to get from Next SSR processing. But I mean, I haven't done any testing of that. I mean, what's your experience with? Because you have more experience with Next Image than I do. I mean, have you found it like? Is there any initial like delay when you get that image? And you said you've used Cloudinary and other services. Like, do you find that that's faster?
Yeah, there's definitely been a delay, and you're saying you're talking about like the caching level, and that's one of the beauties of a Cloudinary is you hit it the one time, and unless you change that source, which I'm not even sure you're able to do, that the cache version is there. I don't know this for sure, but I'm thinking that cache will regenerate in some build processes. Next may not do it, but I'm guessing other frameworks do as well. But yeah, Cloudinary has definitely sped up our process of delivery. And so good for the user, also great for the developers, because we don't have to care about the size of the image. We just like take the screenshot, throw it in Cloudinary, grab the dimensions, and then put it on the page, and we're done.
Yeah, yeah, and I mean, it's like even now, I use CFE as an example because it's like my one bigger side project, and it's been running on Hugo forever, and Hugo pipes can process images. Obviously, given the nature of Hugo, that's all build time. It processes build time. It spits out variations of those images as needed for, however you specify them in the site, right? So, but it only does a single format. I don't know if you can actually specify different formats now. I haven't tried it. It's been a little while, but at least one of the things that I get dinged on, like the web performance, like the Lighthouse stuff, is use newer image file formats because and I can't easily do that if I'm
right.
Even this way. Like it's a big process to go through and change all of that, while also supporting people who are on a browser that may not be able to support some of these file formats. And I don't know all the ins and outs of like what browser supports what formats, but it is a big deal. I think this at least is an easy solution to say like, okay, I don't need to worry about it because I'll let Cloudinary deal with it, and like it'll serve up whatever image format it should that's best in this situation, and I don't even need to think about it.
Exactly. I think that's one of the beauties of this modern architectural patterns where everything's composable and stitched together. It's like, well, if you choose to bring this thing into your application, then it's your responsibility to do all this work and understand. So it's like, well, if you want to optimize images and you're responsible for it, you have to deeply understand how images work, where in this way we can rely on a third-party service, take advantage of all the work that they're doing, and those folks focusing exclusively on that. And the other thing it made me think of, which it came up in a talk yesterday, is that there's more you can do just in terms of what these images can become, and it's not just about performance. And I thought Colby showed an example really great where he added the text, he added the background, and I got really excited later in 2022 when Next announced that they had this service to be able to more easily generate SEO meta images for your sites. And it's a cool feature. But now seeing this presentation from Colby, I'm like, well, yeah, but maybe we don't actually have to do all of that work. Maybe we can rely also on these services and give it some template and then let it generate these unique images for every page on our sites.
Yeah, I know it's definitely something I've thought about. I actually want to go back and take the scraping process that Queen Ray showed in the prior one with because, for instance, like I do a lot of crowdcasts and things like that, and they don't, so I was like, oh, this would be really cool. You could combine that with like a Cloudinary, like, okay, I'm pulling all those files local and then actually push it out, use that Netlify plugin where it automatically pushes them all to Cloudinary, and then it's like, boom, image problems solved. I only have to upload them once, because right now it's like, okay, upload it to Crowdcast, upload it to the site, upload, and yeah, so I think there's even more than just like, oh, hey, I'm probably not the ideal person for dealing with optimizing images anyway. I know enough to like kind of get them down to something reasonable, but I'm not an expert on it. And then on top of that, I have to like, I don't even, once you add on the fact that I have to then upload this image here, upload the image there, but when you're combining all these services, if you just have a single source of truth for your images, it can really improve your whole developer workflow.
Exactly. And I think they're also thinking about, again, not just the performance or the way that you can manipulate the image itself, but then how does that get presented and passed on to the user? And I loved the example, and I think you made a comment right after with the layout shift. It's like you hear layout shift and you think like, oh, recipe website or news site, and I'm just cringe. I'm like, I hate this experience, and I click on the wrong thing.
Oh, yeah.
So I love that they're thinking about that as well. It's like, yeah, put this image on the screen, and we know immediately it's going to take up this amount of height, and your stuff's not going to move all around.
Oh yeah, I can go on a rant about the layout shift. I don't know how many times, and I get stuck in this like perpetual loop where it's like I go back to click on the link that I intend to, and then I try to click on it, and as soon as I do, layout shifts, I'm like, duh, again, it got me again. How many times am I going to do this? So anyway, yeah, I think these are all great, and we obviously talking about images. Yesterday we talked a lot about video, and even he mentioned audio being in there is like, I think something. Not everybody's dealing with audio that much. Some people are doing podcasts. You might know some of these people doing podcasts, so maybe that's like, an option for podcasting and things like that. But just kind of handling all of your media in a central location to me makes a lot of sense. And it's been one of those things on my like to-do list for CFE, like, okay, let's get this all done. So I stopped trying to deal with it and not dealing with it correctly. So, I think these are it's not Jamstack per se, but it's part of what we've been focused on here. Is part of what makes Jamstack, like one of the things we're trying to do is deliver the fastest possible site that we can using all these tools and services. So images and media play a huge role in that.